I don't think anybody thought polar was difficult learning about that yesterday, but if you didn't see it, you might be like, what is she talking about? So just make sure you find the time to get caught up. What we're doing today is converting from polar to rectangular or rectangular to polar, back and forth in ordered pairs, coordinates, or in equations, okay? So we have 4 formulas that help us do that, and I'm going to go over those and where they came from and how we use them in a moment. Just like yesterday, though, I'm going to draw something for you. You don't need to draw it. Just sit back and enjoy my artistic abilities, and then I'll tell you what you should write in notes. So you don't need to write this at all, okay? So yesterday we talked about rectangular and polar and what's the same and what's different. So as a reminder, rectangular, to get to a point on the rectangular plane, we would travel to it x distance left or right, y distance up, right? And we would get to this point, and that point is called x and y, right? This is how we graph in algebra forever, left or right, up or down. Polar is just another way to travel on the same coordinate plane, okay? So I'm going to estimate, where was I? I'll just do 1, 2, 3, 4, 5, 1, 2, 3, 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. So to get to this point, which is in the same place on the coordinate plane, it's just a different way of traveling. The way we get to a point with polar is by going a distance right from the pole or origin, that's called r, out to a theta on the unit circle. So in polar, we have r's and thetas. X's and y's, rectangular, polar is r and theta. If I took a rectangular graph and a polar graph, and I graphed the same point, I graphed their equal points on the same one, well, that's not going to make sense. I'll talk about that more later. But let me put those two together. So putting that all together, to get to a point, pretend that's the same point, I don't know. We could call this x and this y, right? Which makes a right triangle, by the way. We could call this the radius and call this theta. That's putting both of them together, because what I was about to say and what I'll make a point of more in a minute is that whether you graph a point, there's a relationship between the two. I'll come back. It's not going to make sense until I get to the problem. Sorry. All right, so I'm going to redraw that on this little space right here so we have that to look at. That's going to help us understand these 4 formulas. So again, to get to this point, we could call this x, this y, this theta, and that r. Okay, and all 4 of these formulas come right from that triangle. What I want you to notice about all 4 of these formulas is that on one side of the equation, all 4 of them, you have x's and or y's, and on the other side of the equation, you have r's and or thetas. Rectangular always uses x and y. Polar always uses r's and thetas. So what we're going to do in a minute is change x's and y's to r's and thetas to x's and y's using these formulas. I'm going to take a quick second and go over where these formulas, how they develop them though. So these 2 are used to go from polar to rectangular, okay? So if you use this triangle and you ask yourself, what is cosine of this theta? Remember SOHCAHTOA, cosine is adjacent over hypotenuse. So x is my adjacent side, r would be the hypotenuse. And then I don't want to have mixed letters on one side. I don't want x's and r's mixed together. I want to separate them, polar letters versus rectangular. So I would multiply both sides by r, and that's how I get x equals r cosine theta. That's where that came from. And I could do the same exact thing with sine. Sine of theta is opposite over hypotenuse, right? SOHCAHTOA. So opposite would be called y, hypotenuse would be called r. Solve for y, multiplying both sides by r, and I get r equals, nope, sorry, y equals, right, y equals r sine theta. Sorry, guys. Like, I've had this weird week of sleep. I didn't sleep more than 3 or 4 hours Tuesday night, Wednesday night. No, Monday, Tuesday, Wednesday night. So I've been super tired, but I've been focused. Last night I slept like 11 hours, and now today I'm like stuttering, can't remember words. I don't know. Maybe the non-sleep has caught up with me. I don't know why. I like wake up in the middle of the night and think about lessons. I actually like think about math in my sleep, and then I wake up and I'm like, oh, I'm going to do this. Like, I came up with, when I get to it, I'll tell you, that came to me 2 nights ago in the middle of the night. It just keeps me up at night. I don't know. I'm a freak. All right, and then these two formulas are to help you go from rectangular to polar. And guys, look at this. Look at this problem right here, this formula. X squared plus y squared equals r squared. What does that make you think of? Pythagorean theorem, right? Look, x squared, y squared, those are 2 legs of a right triangle, equals the hypotenuse squared, which is r squared. So that's just Pythagorean theorem. And this is your quotient identity. Tan of theta equals, go ahead, sweetie, y over x. Y is sine, x is cosine. So that's where those two come from. So here we're going to go from r and theta, so we're going from polar, and we want to convert it to rectangular, which is x and y. And in every single problem today, you're going to be using these 4 formulas, so you want to kind of start getting comfortable with them. So I have this formula that's x equals r times cosine theta, right? I have r and theta. I can use this formula to find my x. So x equals, I have a few left on my desk over there. I'm out of tissues. Our department is out of them. So unless I go buy some, and I keep forgetting, you might want to bring your own tissues. Okay, so I'm just plugging in what's given, r and theta into the equation. Guys, we have to know the trig. Trig is not going away for the rest of the year, and here we have to know cosine of 5 pi over 6. So 3 times what? So my denominator of 6, quadrant 2, would be negative square root of 3 over 2. So I find it. Denominators of 6 are near the x-axis. I can picture that ordered pair. Cosine is negative in that quadrant. So my final answer would be negative 3 square root of 3 over 2. There's my x. Now we use the other formula to find y. Y equals r given, sine of theta also given. What is sine of 5 pi over 6? 1/2. So y equals 3/2. So just understand, if I graphed this point on a polar graph, I graph this point on a rectangular graph and put them right on top of each other, they'd be in the same exact place, okay? The destination is the same. It's how you travel that's different, okay? So understand, just like my analogy yesterday of going from Countryside High School to Countryside Mall, whether I go along the roads, left, right, all of that, I get to Countryside Mall, or I fly in my private jet to the mall, the destination is the same. How I got there was different, okay? So remember, these are in the same exact place, in the same exact quadrant, if you graph them. That's going to be important in a second. All right, let's just do one more of these. X equals r cosine. I want to review with you the negative angles. So I'm just plugging in r and theta into the same formula we just used in order to get x and y. So we have to remember, and we went over it yesterday, again, we've talked about negative angles a few times. Remember, to find a negative angle, think about where it is positive. 7 pi over 6, I quickly know that that's in quadrant 3. because the numerator is 1 more than the denominator. So positive 7 pi over 6 is right here. How do I find its negative? What's the word I used yesterday? Cross the x-axis. You're totally right, flipping, whatever helps you think about it. But remember, no matter where the positive one is, if you cross the x-axis, top to bottom, bottom to top, that gives you the negative. So negative 7 pi over 6 is coterminal with 5 pi over 6. Always the same denominator, right? You're not going to switch to like a denominator of 3. Okay, so that's a easy way of finding negative angles. So the ordered pair of these two coterminal angles would be negative square root of 3 over 2, 1/2. Okay, so I get 2 times cosine, 2 times sine. 2's cancel. X is negative square root of 3. 2's cancel. Y is 1. Okay? Polar to rectangular, again, if I graph them on their separate coordinate planes, they are at the same place on the coordinate plane. Okay? Now we're going to go from rectangular to polar. So we have x and y, and we want r and theta. We're going to use the other two formulas. It should make sense. What do I have? I have x and y. Oh, okay, I need an r. I can plug it right into the Pythagorean theorem one. Show a lot of work, show no work, I don't care. We should be really good at Pythagorean theorem at this point. 1 plus 1, r squared equals 2, square root both sides. Remember, you always get a two solutions when you take the square root of something. But guys, why, anybody know why I would never even use the negative in any of these problems? What's another word for the radius? It's what? The hypotenuse. And the hypotenuse can never be what, May? Negative. Guys, a hypotenuse or a radius or C, whatever you want to call that side, is a distance. It's a length. You can never be negative. You don't have a negative distance from here to a location or side of a triangle. All right, so it's always the positive. And then we'll use the other formula, tan of theta equals y over x, because that's what I have, y over x. Obviously, you could have skipped that step and gone right to this step. Negative 1 divided by 1 is negative 1. We have to remember our tan tricks. When we have a tan value of 1 or negative 1, what denominator of angle is that? 4. Good. Remember, if it's a denominator of 3, it's the square root of 3. Denominator of 6 is square root of 3 over 3. Denominators of 4 are 1s. And then you have to think, okay, so which one now? There's 4 tans with a denominator of 4. There's only 2, though, that are negative 1. Tan is negative here and here. So how do I choose between 3 pi over 4 or 7 pi over 4? Why? It is quadrant 4, but why? Okay, I'll tell you. So remember, the whole point, the reason I just acted this whole thing out, if I take this point and rectangular and this point and polar, I put them on top of each other, they're in the same place. So you all know where this point is. It's algebra. What quadrant is 1, negative 1 in? 4, right? Go to the right, 1, down 1. This guy is in quadrant 4, so guess what? So is this guy. They're always going to be in the same place. That's how I know I'm going to use this one, which is 7 pi over 4. Okay? One more of those. R squared equals x squared plus y squared. Right? So we're going from x and y to r and theta. Again, r is always positive. The other formula, tan of theta, is y over x. Y over x. 0 over 2 is just 0. So now I have to remember where on the unit circle is tan 0. Number one mistake on the trig quizzes, by the way. So let's remember, it's got to be one of the quadrantals. It always helps me to draw that. Up to you. So remember, you either have 0 on top or 0 on the bottom in these four angles. And on top and bottom, we're undefined, right? 1 over 0, negative 1 over 0. Tan is undefined at the top and the bottom. You never have a 0 in your denominator. So that means we have two choices. Tan is 0 here, 0 over 1, or here, okay? Which one are we going to choose? Well, don't forget, this point is in the same place as this point. I know that this point is on the positive x-axis, right, to the right. That means I'm going to use this tan value. So theta is 0 or 0 pi. You can write either one. Okay. So that's how we do it with coordinates. Now we're going to do the same thing, but with equations. So turn the page. So look at example A here. Without even looking at the equation, I know that this is rectangular form. It's a parabola, right? It's got x's and y's in it. This is our normal old rectangular plane type of an equation. What we're trying to do is get rid of anything that's rectangular, x and y, and replace it with r's and thetas, okay? So just to remind you what formulas to use, whether you want to write them or not is up to you. I'm going to be using these two formulas. These two formulas should be pretty easy to memorize. I feel like we've used them before. But also, x and cosine go together, and y and sine go together, right? Ordered pair x and y is cosine sine. Okay. Also, so this is kind of a weird problem, okay? This is the hardest one of all of them. Not that it's hard, it's just got some weird algebra in it. So you definitely want to pay attention and write the steps so you can go back and look at it if you need to. But here's another thing. We're using substitution here. Remember, x is this, r cosine theta is x. Like, they are equal to each other. Just like if I give you x equals 4, anywhere you see an x, you can take out the x and put in a 4, okay? Anywhere I see a y, I can take it out and put in r sine theta. That's what I'm going to do. R sine theta equals, okay, so I just solved one issue. I got rid of one of my rectangular variables, got rid of y. I need to do the same thing for x. 1/2 times x is r cosine theta. Don't forget there's a squared on that x though. And now we have to simplify this, solve this. What is this? Looks like a mess. Well, it's about to get a little messier before it gets simpler. But I want to remind you guys of something. In algebra, if you had to square that, it would end up being 4 squared x squared or 16x squared. You would have to square all of that. In this situation, same idea. R squared and cosine squared. Remember in trig, you put your squared not on the variable, you put it on the word, but you have to square both, okay? And then I just went ahead and multiplied the whole thing by 1/2. It's not the distributive property because there's no pluses or minuses in here. I just did 1/2 times this, so I just get 1/2 of all that squared. Now, here's what you need to know. Anytime you're doing polar form, you have to, I'll get that, solve for r. Solve for r. You need to get r by itself. There's some of them not here. And very few limits left, but you can take them until they're gone. So I have to solve for r. First thing you should notice, guys, is there's r's on both sides, and we have this pesky fraction. So I'm going to get rid of the 1/2 first. Let's get rid of that fraction by multiplying both sides by 2. So 2r sine theta equals r squared cosine squared theta. Okay? So I got rid of the 2, the 1/2, by multiplying both sides by 2. And my goal is to solve for r. Now I have r's on both sides. And notice the r's are like part of they're multiplied. It's 2 times r times sine. R squared times cosine squared times theta, or of theta. So to get those together on one side, I'm just using algebra skills. Like, I know I can divide this side by r, right, as long as I divide this side by r. You can do anything you want to an equation as long as you do it to both sides. And that solves the problem of combining our r's. There's 2 on top, 1 on the bottom, so this one cancels out one of those. There's 2 on top, 1 on the bottom, so the 1 on the bottom is gone, and one of the ones on top is gone. And now you're there. There's one step left. To get r by itself, we would divide both sides by cosine squared theta. So r equals 2 sine theta, right, divided by cosine squared theta. It's a mess. Yuck. Okay. All right, the worst is over. So if you didn't think that was too bad, good. The rest is a lot easier. We have 3 problems left, and they're all examples of going from polar to rectangular. These are they have a lot fewer steps, but they require a little bit of creativity, okay? So let me, again, write those 2 formulas for us so we have them to look at. One of them was like the Pythagorean theorem one, and the other one was our quotient identity of sine over cosine. We're just using y over x, okay? So I look at this first example. It's clearly polar because it's got an r in it. And my final answer, no r. So somehow I have to get rid of that r. And so if I look at these equations, I know it's got to do something with this one, right? Because that's the only one that has an r in it. But is it a typo? Did they forget to square the r for me? Because if that was an r squared, I could just replace it with x squared plus y squared. No, it's not a typo. But using your algebra skills, you want this squared? Square it. Go ahead. What do we just have to also do? Yeah, square the other side. It's fine. So we have r squared equals 16. And now I can take out r squared and replace it. Done. That is now rectangular. This is, by the way, this is a circle with a radius of 4, just so you know, because I think you have to sketch one in the homework. So you're just going out forward all directions. That's what that is. That's going to become something we learn really deeply next week. Oh, right here. Next week when we have a little bit more time, I'm going to have calculators side by side. I'll have one calculator with this equation in it. By the way, you can graph polar equations on here, which is going to help you with your project next week. But anyway, I'm going to have one calculator with this equation in polar form, and then I'm going to have another calculator right next door to it, side by side, with the algebraic one. And what you're going to see is both of these are the same circle. They're both a circle with a radius of 4, different ways of graphing it and traveling around the coordinate plane, but the same graph. This is what I woke up in the middle of the night thinking about. Oh, I can show it to him by putting 2 calculators side by side. Like, what am I thinking about in the middle of the night? Who knows? All right. This second to last one, we have 2 more. This one, I have a theta, so I'm clearly going to have to use this formula, right? So think about what tan of theta is. Our theta, I'm going to replace with 2 pi over 3. And that equals, tan of our theta is y over x, right? Tan of theta. So then I'm just going to put the y over x here. So all I did is take that equation and put in the 2 pi over 3. Now, what is tan of 2 pi over 3? Unit circle again. What's all of my denominators of 3 have a what as their tan value? Square root of 3. I think that was May. Thank you. Remember, if it's a denominator of 6, square root of 3 over 3. But don't forget to check the sign. All students take calculus. Tan of 2 pi over 3, that's quadrant 2. I know that quickly because the numerator is 1 less than the denominator. Tan is negative in quadrant 2, right? Only sign is positive. That means by default everybody else is negative. And we successfully got rid of theta in the original equation, but let's just clean this up one more step because this is algebra. Algebra, we don't leave y over x. We would get the y by itself because guess what? This is an equation. I mean, this is a line. This is a weird decimal, but it's just x to the first power. If I graphed that by hand or on my graphing calculator, it would make a line. So with this, again, the side-by-side calculators, when I do that, I will show you how this is the same as this, just different ways of moving around the coordinate plane. Last question. Last one. Next page, example C, or I don't know what, I think your notes look a little different. I don't know. Last one. I've got r's and thetas, got to get rid of them. Well, first thing I do notice, though, guys, is cosecant. There's none of my 4 formulas have any weird cosecant friend stuff in there. I can use my reciprocal identity knowledge and change it to sine. Remember, every C needs an S, every S needs a C. Cosecant is the flip of sine and vice versa. And if I put that together, I get that. Now, I still haven't solved the problem of getting rid of r's and thetas, right? But there is one thing, if you kind of take a second and look at it, you could do 2 things. You could be like, I don't know what I'm supposed to do, but I could get rid of this fraction by multiplying both sides by sine. Or you could be like, oh, wait, I kind of can see how I might be able to use this formula. Because if I multiply both sides by this denominator, I get r sine theta, right? When I multiply those together, equals 2. And now, since r sine theta equals y, I can replace r sine theta with y. That's just a horizontal line at 2. And so would that be if you graphed it. Okay? All right. Page 167. Same page we started on yesterday. I know it's annoying to write all those problems down, but it's easier than me. It's still less work than me saying do 7 through 24 all, and just pulling a few of each, okay? So be annoyed, but I could not annoy you by saying do 7 through 24 all. Then you'd be annoyed if I gave you all the problems to do. So just write it down. You should be writing so I can put the key up completely, please. All right, so Dan is Tuesday, 4th period. Who else? Lily, when do you take? Did you take the quiz yet? You didn't. In the morning, okay. And I don't care. I mean, I'm here that whole time, so even if it's like the last hour or whatever, whatever works, okay. Just you want to give yourself the whole class period. Yeah. All right, I'm going to put the key up, or the beginning of the key. 7, 8. I had originally assigned 9 and 10. I cut it just because to shorten the assignment. So if you go on Canvas, if you felt like you wanted more to practice, I don't know if anybody would, I did put those. They will be on Canvas, but you don't have to do them. I crossed them out. I can fit all but the last 2 on there. Give me one second. I'll come around and help y'all.